Hello everybody. In this video we're going to take a hypothetical example which includes an application of using the concept of limits. So here we have a target and we have a source, signal source, and the signal has to be sent to this target, and this target is, say, at a distance of 100 miles from the signal source. Let's assume for the time being that the signal cannot travel all the way in one day. It can only travel whatever the distance it is at, half of that. The signal started at day 1 at 100 miles. On day 2, it will be at half of 100, which will be 50 miles. On day 3, it will be half of 50, which will be at 25 miles. On day 4, it will be half of 25, which is 12.5 miles from the target. And on day 5, it will be half of 12.5, which is about 6.25 miles from the. This picture here shows the distances on different days from the target. As you can see, it went from 100 to 50 to 25 to 12.5 to 6.25. So the question now arises, will it ever reach the target? Turns out it will always have some distance from the target, and it can only go half of that distance. So it will, theoretically speaking, never reach the target. Practically speaking, we can't have that kind of a situation because we have finite sizes. In any case, this is an example which can be modeled by this equation. What we have here is n is the days. So we are increasing the number of days, and goes up to anywhere all the way up to infinity. We don't care. And x is the distance from which we are starting. So we're starting with a finite distance, and we let n go on. So theoretically, it will take us infinite amount of time to reach the target because we can never actually touch it. If we let n go up to infinity, limiting value of this expression is 0. Notice one thing. When n goes to infinity, we will get closer and closer to the target. And it doesn't depend on the initial distance between the signal and the target. This x could have been 100 miles, or it could have been 100 light years. If we let n go to infinity, eventually this will become 0.